Welcome to Magnetized Labs. Today we are going to see the design of solid-state relay for DC applications using optocoupler in KiCAD. What is solid-state relay? An SSR is an electronic switch that controls a high-power circuit using a low-power signal, but that can be done using traditional mechanical relays also that use physical electromagnets and moving contacts. But SSR rely entirely on semiconductor switches such as MOSFETs, thyristors to pass electricity. This is the block diagram of the design of SSR. We have used a P-Channel MOSFET and an optocoupler circuit for making the circuit work as an SSR. An additional feature, we have added an indication LED to denote that the circuit is turned on and turned off. We have used a mounting hole for input and output connections to handle high current applications so that the wires can be connected through U-lock and round lock. The signal input also has been given with the mounting holes, and this can be given from any microcontroller or PLC. The specifications of our design, which is having the contact rating of 5 to 60 volt DC, it is rated for 35 amperes of continuous current, and the signal type you can give from 3 volt to 32 volt DC to turn on this SSR. This is compatible for 3.3 volt, 5 volt and even 12 volt for PLC applications. Coming to the schematic, as I said in the block diagram, we have used mounting holes for signal input and even power input and output connections. This functional circuit needs a return path for power ground also. Since we are using an optocoupler circuit, power input is directly connected to the source of the P-channel MOSFET. This FOD817DS is an optocoupler. It is used to turn on the power MOSFET and to isolate the power circuit from the control circuit so that we can prevent the control modules such as microcontroller, PLC or any sensitive devices which will be operating in lower voltage levels from the effect of damage in the power circuit. That is how the isolation between control and power circuit is achieved. Until unless this optocoupler is triggered, this P-channel MOSFET will be turned off because there is a body diode which is also in the opposite direction of the power flow, and there is no signal for SSR trigger. This transistor inside the photocoupler will be turned off, so there will be no connection between 4 and 3. This will be open circuited. The total voltage input whatever we are giving will be directly applied to the gate. So the difference between the gate and source potential will be nearly zero. So this P-channel MOSFET will be turned off. Once we give the signal input high, that means if we apply 3 to 32 volt at this pin, so this LED will trigger this transistor inside the photocoupler. This will be connected to the ground directly. So this P-channel MOSFET will be turned on. From 5 volt to 12 volt, whatever the voltage we give, half of the voltage will be dropped here and then half of the voltage will be dropped here. Beyond 12 volt, this Zener diode at the gate to source terminal will clamp the gate voltage to 12 volt. That means with respect to gate, the source will be 12 volt. So with respect to source, the gate will be minus 12 volt. At that time, this MOSFET will be turned on. Then you will get the output here, and then the LED will be turned on. The same circuit has been verified with the simulation also. Yeah, so this is the signal input for the photocoupler, and then this is the input source for the power supply input to the SSR, and then this is the output. So we have actually monitored the gate signal also. Yeah, so this is signal input. This pink color waveform is the signal input whichever we are giving from the microcontroller or PLC or any trigger signal from the output side from the user end. At the same time, the gate voltage is also going to minus 12 volt, which is to turn on the P-channel MOSFET. Other than that, if we give the zero voltage input at the signal side, even the MOSFET gate to source terminal also is getting turned off. MOSFET will be turned off. At the same time, the 60 volt will be receiving at the output end with respect to ground. This is how this circuit works. In PCP, yeah, the same setup. So we have given the mounting hole input for signal and even for the power input and output terminals. This is the high power P-channel MOSFET. We have used a big plane to conduct the whole amount of current. If you want, you can add a little bit bigger plane also when you are designing, or even if you want, you can add a piece of heatsink on top of the P-Channel MOSFET to manage the thermal performance. Input is connected to the source of the P-Channel MOSFET and the Zener diode, then the resistors. This is indication LED, photocoupler for isolated triggering. This is the 3D part. So P-Channel MOSFET and then Zener diode, indication LED, and then photocoupler. These are all input and output mounting holes with the labels written on that. Only one resistor has been placed on the bottom side. That's it. Coming to the applications part of SSR, this has been widely used in battery and energy systems, robotics, automotive systems, industrial automation, solar power installations, electric vehicles to turn on and turn off the loads, DC motor control, process control, and heaters. That's it. Thank you for your support. If you have any queries or feedback, please let us know in the comments. We are happy to help. See you next time.